Okay, so today we're going to be doing vector spaces, and we're going to be determining whether the set is a vector space or not. So the first thing we want to do whenever we have a question like this, we see we have a set of 4 variables. We have a minus 2b equals 4c, 2a equals c plus 3d. The first thing we want to do whenever we have a question like this, we want to rewrite these so that they equal 0. So this would get us a minus 2b plus a minus 2b minus 4c equals 0. Then 2a minus c minus 3d equals 0. We can rewrite this as a matrix like this. 1, negative 2, negative 4, 0. 2, 0, negative 1, negative 3 times the set a, b, c, d, and set that equal to 0. This is commonly known as the ax equals 0 form, and we're going to want to know to put this into the ax equals 0 form after we find out when it's equal to 0. So once we do that, we can row reduce the following equation to make it in pivot form. And the way we can do that is we have row 2 equals row 2 minus 2 times row 1. So we have 2, 0, negative 1, negative 3, minus 2, negative 4, negative 8, and 0. So we get 0, 4, 7, and negative 3 here. So now we see that our matrix is going to be in this form. 0, 4, 7, negative 3. And we have 1, negative 2, negative 4, and 0. Then again, we have these multiplied by a, b, c, d. That equals the set of 0 vectors. We can say that this is the null space of A. W equals null of A. And then we have to use a theorem. The null space of an m by n matrix. Note it's m by n, so it's not going to be a perfect square, right? This would be an n by n matrix. An m by n matrix is going to look more like a rectangle. So keep that in mind. A is a subspace of R. R to the n. So now that we have that theorem, we can see that this right here, this one's a 2 by 4 matrix. Means 2 equations, 4 unknowns. So now once we have this, we can say that W is a subspace because W is a set of solutions. Therefore, W is a vector space. So we have for our first question, yes, it is a vector space. Let's do another one. Number 12. So we have right here b minus 5d 2b, 2d plus 1, and d. And then the only conditions we have are that b and d are real. According to the above, we have that W is a subset in R4. And so for W to be a vector space, it would have to be a subspace. But we see right here we have 2d plus 1 equals 0. So all this is going to have to be equal to 0. There's no way for d to be equal to 0. Because we also have d equals 0 right here. Right? We need both of these to be equal to 0. And we have d equals 0 right here. It's important to know that this is very important to realize. Because we're going to have basically this set of vectors right here, b minus 5d, 2b, 2d plus 1, and d. And they're all going to be equal to the 0 vector. So right here we have d equals 0, right? But when we plug that in, we get 1 equals 0. Because we plug in 2 times 0, it's 0, plus 1 is 0. And that can't make sense. That does not make sense. That's gibberish. 1 is not equal to 0, 1 is 1. So this is not a vector space. So that's our answer for that question. Let's do another one. Let's look at this one right here. So, like I said before, we have to set this equal to 0. C minus 6d equals 0. D equals 0. C equals 0. We get 0 minus 0 equals 0. So all of these check out. Another way you can see if this is a vector space is you can rewrite this as C minus 6d, where D and C are right here. We can also write this as C 101 plus D negative 610. And then we can say that the column space of this matrix spans the vectors of 101 and 610. So it would be a vector space. All right. What I want to do is I want to try another question. want to try. Let's do number 12 real quick. The ones you sent me. I'm going to load up a new page. Three P minus 5Q, 4Q, P, Q plus 1. And then we have P and Q are real. So, first thing we have to do, we have to set this equal to the 0 vector. All right. So we see here, P and Q must be equal to 0, right? Q here is equal to 0. Because 4 times 0 has to be 0. P equals to 0. If Q is 0, 0 plus 1 does not equal 0. So this is not a vector space. Makes it not a vector space. Because it's inconsistent. It just doesn't work. 1 is not equal to 0. That'll never make sense. We're going to look at this last question. So this has two parts to it. A is going to be equal to 2, 1, negative 4, and 3. And then 6, 3, 12, negative 9. We have to find K such that the null space of A is a subspace of R to the K. We should observe here that this is an m by n matrix, right? We said earlier that an n by n is a square, and then m by n is a rectangle. Except this time the rectangle's like this. Just a little side note, we already know that. So we have that m is equal to 4 and n is equal to 2. You can do it the other way around as well because it's multiplication, works either way. So we need column of A to be a subspace of when RK where m equals k, which equals 4. Therefore, we need r to the 4, right? So the k value we need equals 4. It's asking for the column space right here. We know these are rows, these are columns. So essentially the required value is going to be whatever size the columns are, which in this case is equal to 4. For the null space, this is going to be different. The null space is going to be R of k, where n is equal to k, which is equal to 2. And the null space is looking at the rows. So in this case, we see that the rows are length 2. Therefore, the desired k value for part A is going to be 2. And the desired value for part B is going to be 4. Let's do one more. We have right here, we have a column of 5, negative 2, 3, negative 1, 0, negative 1, 0, negative 2, negative 2, and negative 5, 7, and 2. Again, we want to find, for part A, we want it's r to the k right there. So let's look at this. Remember, we said null space is going to be like the rows. This is an m by n matrix, where m is going to be length, and then this is going to be the height. However, again, we said that the null space is looking at the rows, and we can see that the rows have 3 entries. So this would need to span R3. So in this case, k is equal to 3. For the column space, we're looking at it this way, and we see it has 4 values. So it has to span R4. Therefore, k is going to be equal to 4. That's your answer. Hope this video helped. If you have any questions, leave them in the comments down below.